In this section, we're going to talk about the basics of using the Rust type system in your own programs with structs and enumerations. Specifically, in this video, we'll discuss structured data, also known as structs or data structures, which involves building up sets of data in structured and ordered ways. Rather than go through slides, I think I'll just show you this in the form of code. So if you want to follow along, pull up your editor and let's get coding. So here we have an editor up with Rust available, and we're just going to edit main.rs. You can make a new cargo project, you can use the compiler directly, you can even use the playground for this, whatever you want. So the basic idea of a struct, it starts with the struct keyword, and then you can name it whatever you want. Let's call this one foo. And then within the struct, you can declare what are called its members. So in this case, foo is going to have quacks, which is going to be an I32, and baz, which is going to be, let's say, a string. And we can do lots of things with foo. So let's make a main function. And in our main function, we could, for example, say let a equals foo. And this is the syntax to instantiate a struct. So up here, we've declared it. So now the name foo means this type of structure. It's a type. And then within the main function, we can actually instantiate it. And we'll do that by, for example, quacks is going to be 10, and baz is going to be, let's say, string new. It'll just be empty. Okay, and then because this is a statement, we'll finish it off with a semicolon. We didn't do that up here because this is an item, not a statement. It's not inside any kind of function. So now you see that we're getting warnings on this because we don't use these at all. Field is never used, baz, but that's okay. We can go ahead and use them here. So we can println, and let's just do foo. We're going to sort of replicate the structure here, but not entirely. Oh, that's not going to work, is it? Because of those braces. So instead, I'll just do this. Foo quacks is one format, and baz is a second format. And we'll just say a, which is that we just instantiated. And you can see my IntelliSense here is showing me that I can pick either baz or quacks because those are the members. A dot baz. And this syntax is going to go ahead and look at A. The dot says, look at A, look at something inside it. That something is named quack. So if I go ahead and run this, you should see, I did not save the file. That's important. So if I actually save the file and then run it, we'll see that we get an output of foo is quacks, which is value 10, and baz, which is value nothing, because we made a string that was nothing. We could also make this an actual value. String from could be, for example, hello world, and we could simply say, okay, cut that back to where it was string new. So we could actually make this be string from, and it could be from, let's say, hello world. And if we just go ahead and save that and run it, you'll see that we get the output we expect. So what we're doing here is we're essentially providing a structured way to store data. Now, structs can, of course, contain other structs because they are just regular types. So we could have struct fuzz, and inside here we could have z and I32, and then we could change foo to have z is of type z. And so now foo can contain a z. Now, one thing that's interesting to note is that the compiler enforces that these are fully filled out. So if we go ahead and try to run this, you'll see that we have a problem. Z not found in scope because I named it z instead of fuzz. So again, compiler strictness is useful here. And in addition, we get missing field z in initializer of foo. So unlike, for example, JavaScript, we can't simply omit fields from structs, or what would in JavaScript be objects, which can lead to all sorts of runtime issues. Rust, of course, as with many languages, is going to prevent that. So in here, we can just say z fuzz z 4. And then in here, we could do z fuzz z. And of course, I'm just writing these out. You don't actually have to write that out in order to access it. We're just writing that to display more clearly what's going on. So then we could say a dot z dot z. And if we save this. You'll see that it's auto-formatted for me because the line got too long, but the code is the same. So we go ahead and cargo run, and we get foo quacks 10, Baz hello world. Z is a struct fuzz with a field Z, which is 4, which is exactly what we set it to. So structs are incredibly useful, and most projects will use them in some way. So a great example of this is when you have to store the same type of data, but tagged in different ways. So we could, for example, create a type. We could say type point equals a tuple of F32, F32. That would work as a point, but it might be easier and more ergonomic to do, for example, struct point 2D X F64 Y F64. And this is going to go ahead and give us essentially the same functionality, but we now have named fields. So for example, we could go ahead and erase all this and do let P1 equals point 2D X is 10, Y is 20, and those do need to be 0 because they are floating point. And then we can do whatever we want with P1. We can also take structs as arguments to functions because they're just regular types. So we could do fn add points, A, point 2D, B, point 2D, and this will return, of course, a point 2D. And in here, we'll just do, and again, we're using expression syntax here, so whatever we write, since it's the last value evaluated, it will be the return value of the function. So we'll do a.x plus b.x, and a.y plus b.y, and we have to annotate those with the names of the field, so that will be x and y. And if we go ahead and save that, we should be able to see that it does compile, and we can call this function. So we could say let p2 equals point 2D x minus 2, y, say 30.5. And we can go ahead and use this function. So we could do println, and we'll just do the 1, add points, p1, p2. Now, this function returns a struct. So if we use the dot syntax, the same thing will work. So we could do add points p1, p2 dot x. And that's going to go ahead and take that return value, which isn't bound, but it is still a structured return value. And we can go ahead and run this program. And it's going to go ahead and spit out 8, which is in fact what 10 plus -2 should be. So you can see that structs are a great way to lend some structure to your data. You can combine them together, you can pass them into and out of functions, and they are just regular types that the user gets to define.